Teleport engineers are the hands-on guardians of the satellite ground infrastructure. Their job is to make sure everything at the teleport, from the large satellite dishes to the smallest coaxial connector, is working smoothly. They install and maintain antennas, RF chains, modems, and other critical equipment. When something goes wrong with the signal, they're often the first to jump in with a spectrum analyzer or swap a faulty modem. Teleport engineers also collaborate closely with NOC and RF teams to ensure the satellite link stays stable and customers don't experience service interruptions. Without them, there's no reliable connection between the sky and the ground. Teleport engineers are the on-site experts ensuring the satellite ground infrastructure runs smoothly. They maintain and align large antennas, RF chains, and critical equipment like bucks, LNBs, and modems. They're responsible for installing and troubleshooting IF and L-band components, making sure signals flow correctly through every cable and connector. Before activating a new site, they may conduct a site survey or perform an antenna lineup to ensure optimal performance. Teleport engineers constantly monitor signal quality using spectrum analyzers and carrier monitoring tools. And during outages or maintenance windows, they act as the hands and eyes for remote teams, supporting the NOC, RF, and IP engineers. Their work also involves coordinating with satellite operators and ensuring everything at the teleport, including grounding, cabling, and cooling, meets professional standards. Without them, there's no stable bridge between the satellite and the terrestrial network. Let's take a look at what teleport engineers typically do on a daily, weekly, and occasional basis. Each day, they monitor the health of the RF chain, checking devices like bucks, LNB, and modems. They use tools like spectrum analyzers to make sure signal levels are within expected ranges, and jump into action when alarms or equipment alerts pop up. Physical inspections, temperature checks, and supporting service activations are also part of the daily routine. Once a week, they dive deeper, performing preventative maintenance, checking grounding and cable integrity, and coordinating with the NOC or RF teams to troubleshoot persistent link issues. They also ensure all documentation and inventories are up to date, and verify that test equipment remains properly calibrated. Occasionally, teleport engineers step into more complex tasks, like supporting beam switches, installing new antennas, or participating in root cause analysis after signal degradation. They may also assist third-party technicians, supervise site work, or even mentor junior staff to pass on their expertise. Teleport operations are critical for satellite connectivity, and these tasks keep everything running behind the scenes. Teleport engineers work directly with the physical and RF layers of a satellite network, so their hands-on skills are crucial. On a daily basis, they align antennas, analyze spectrum plots, and configure modems to establish clean, stable links. They install and patch IF and L-band cables, check signal levels with power meters, and ensure everything is properly grounded and weatherproofed. Precision and attention to detail are essential when dealing with this kind of hardware. But it's not just about what you do, it's also about what you understand. A strong grasp of concepts like link budgets, polarization, SNR, and EB over NO helps engineers make better decisions in the field. Understanding TDMA or SCPC systems, VSAT behavior, and even some IP basics allows teleport engineers to collaborate effectively with NOC and RF teams. Knowing how the whole system works, from modem to satellite to remote terminal, makes you a far more valuable asset. Teleport engineers work in environments where quick thinking and physical precision go hand in hand. Hands-on problem solving is a must, whether you're adjusting an antenna in the middle of a storm or swapping a modem under pressure. You'll also need strong analytical thinking to interpret signal behaviors, recognizing when something's off and understanding what might be causing it. Pattern recognition is key, whether it's a drop in ebb over no or a sudden alarm from the RF chain. Spotting trends early helps prevent outages. Since teleport operations rarely happen in isolation, you'll be coordinating closely with NOC, RF, and IP teams. That means clear communication, both verbal and written, is essential. Attention to physical details like grounding, cabling, and weatherproofing is part of daily operations, and you need to stay adaptable when things go wrong. Whether it's a cable break or unexpected interference, you'll be expected to act fast and safely to keep things running. Finally, site safety and proper equipment handling aren't optional. They're part of the responsibility that comes with being on the ground. Let's be honest. Teleport engineering isn't typically an entry-level role. Employers are looking for people who already know their way around a satellite chain, both physically and operationally. That includes field technicians with hands-on experience in satellite, RF, or broadcast systems, people who've aligned antennas, swapped LNB, or diagnosed signal loss in the field. It also includes NOC or RF support staff who want to transition from remote monitoring to direct on-site work, and engineers who've spent at least 2 or 3 years configuring modems, aligning dishes, or maintaining RF chains. Professionals from telecom or broadcast backgrounds who've worked on signal routing and site infrastructure are also great fits, especially those familiar with things like waveguide systems or indoor-outdoor patching. And finally, a lot of teleport roles go to ex-military or maritime communications technician, the kind of people who've operated VSAT terminals on ships or in the field and know what it means to keep a link alive in tough environments. As a teleport engineer, you'll regularly work with spectrum analyzers from brands like Norsat, Avicom, or Keysight to monitor carrier signals. Power meters, L-band testers, and signal generators help you validate the health of RF chains on site. And when it's time to configure a link, you'll use modem-specific tools like iSight from iDirect or SatNet from NewTek. You'll also need to be comfortable using waveguide tools, torque wrenches, and proper grounding gear. Everything must be tight, aligned, and safe, especially when you're working near high-power bucks. You'll come across equipment from vendors like CPI, NJRC, Hughes, and NewTek, and sometimes very large systems from GD, Satcom, Vertex, or VSAT. Knowing how to integrate and monitor these using systems like Dataminer or Kratos can make a huge difference in uptime and troubleshooting. When it comes to certifications, the GVF Professional Series is one of the best-known industry paths. Training from modem vendors like iDirect or Hughes is often required to access their systems. Many employers also value basic RF safety or OSHA awareness, especially if you're working on towers or high-power transmission systems. The teleport engineer is responsible for maintaining the physical satellite ground infrastructure that connects remote terminals with the network core. You'll work with antennas, RF equipment, modems, and monitoring tools. You must understand RF signal flow, equipment alignment, and site best practices, as well as how satellite-specific factors like polarization, power levels, and signal-to-noise ratio affect link stability and performance. If you're aiming to become a teleport engineer, the best way to start is by supporting the field techs. Helping with antenna installations or modem replacements gives you hands-on experience that builds your foundation from day one. Pay close attention to the senior engineers on site. Watch how they align antennas, troubleshoot RF chains, and deal with unexpected signal issues. This is the kind of practical knowledge you won't find in textbooks. And finally, as you grow, aim to see the full signal path, from the satellite dish, through the modem, and into the IP network. Understanding how all the layers connect is what turns a technician into an engineer.